Anyway, so like I already told you what probability was, and then like Kaisha told us how many when we initially had 10 of each animals, and then how we would pick one animal that's like not the boss. And now what happened is that these elephants started having kids, and they went mad, and they started killing foxes because they thought the foxes were trying to eat their kids. So yeah, the elephants, just kind of body slammed the foxes, and they died, and they killed the boss fox too. So
Was
now,
it WWE?
if we were to pick animals, if we were to pick an animal at random, what is the probability that it's either a fox or a rhino? Who's taking this one? Alright, participation would be appreciated. And today is the day your progress reports go to your parents.
Fitona, could you please
One
repeat?
try,
You
one try.
you broke up.
One try.
Oh, what's the last thing that I said?
I heard you say like rhino or something. All
Oh
I
yeah,
heard.
what is the probability that if we picked an animal with this setting, that it's either a fox or a rhino?
Hmm.
I want to answer the
Wait, and
question.
the
Okay.
and the boss fox is dead, right?
Yeah, the boss fox is dead.
Hey,
Yes, Pradyum,
Okay,
go.
so there's three fox.
Pradyum, go.
four, 4 out of 40.
4 out of 40.
So box fox is not
Yeah.
there. Is it still
Sorry? Kaisha, what was
if
your
the
question?
if the foxes are four, so there is no boss fox,
Yeah, he's
and there
dead.
are three foxes or still four?
No, there's still 4.
Okay.
What about elephants? There's 16, so there's no boss one.
There is a boss elephants. Dude, the elephants just had kids. And they were scared that the fox was eating them. So they killed the foxes. Just a
Alright.
simple. He took him. They Kobe'd a few, and then they body slammed a few.
Kobe and Watson. Alright, fox, rhino, which is 10/40.
Is it
And the
14
inter-
40?
Yo, what is the intersection supposed to be?
Wait up. There are two people talking. This was Pradyum's question, Kaisha. You can send me the answer on WhatsApp and I'll check it. But, yeah. Pradyum, yeah, just use your judgment. Read the question again, or I'll read it out to you. It's either a fox or a rhino.
Oh, alright, so 40. I got my answer.
Very good, Kaisha. Yes, what's your answer,
I
Pradeep?
got my answer. 13/40.
What out of 40?
13.
13? How did you get 13?
Yeah. 4/40
Yeah,
plus 10/40
yeah, yeah,
minus
yeah.
1/40.
Why are you subtracting?
Huh? It's the intersection because it's an or.
Okay, is there. I thought foxes and rhinos were two separate animals that don't have anything in common.
Oh, that is 14/40.
No, but why are you subtracting? Is there any fox that could be called a rhino?
No. I thought it was a union. My bad.
Stop using those terms that I didn't talk about. Apply the common
I
sense,
also
man. This is unacceptable.
14/40.
Yeah, it is 14 over 40. Think a little before go to conclusions. Right.
Okay.
So, out of the rhinos, we have 5 gray rhinos and 4 black rhinos and 1 what's that thing? I saw a brown rhino. I've seen these in Africa. At least Animal Planet, I've seen them. And now among the hippos, we have 9 gray hippos.
How many black rhinos do you have?
I have 4 black rhinos. Because I imported them from Assam.
What about brown?
Only 1. I bought them from Africa.
So 5 gray, 4 black, 1
Yeah, I'll give
brown.
you the numbers again. And 1, we got like, kind of brownish black. Or actually, yeah, we'll count the hippo as black because I've never seen a brown hippo. I've seen gray and black, but not brown. Alright, now the elephants. We have 10 gray and 6 black. And the foxes, they're all like, 2 gray, 2 white. Yeah, the scary white foxes. The elephants never fought with them. Because they were scared, because they were from Russia. Okay, anyway. Now, the question is, if I were to pick an animal at random, right? What's the probability that the animal is black, has a black skin? Who's taking this one?
I would like to try.
Wait.
Okay.
Oh,
Actually,
Pritamana, can you?
You can send me your answer on WhatsApp and I'll check it. But yeah, Lucky, you can take this one.
Oh, wait, you said, what are the chances of the
Animal having a black skin.
animal having a black skin? All right. Mm, is it 11 out of 40?
How'd you get 11?
Because there are 4 black rhinos,
Yeah.
one black hippo, and 6 black elephants.
Okay.
And there's a total of 40 animals, so I'd added all the black animals, and I got my probability 11 out of 40.
Very good. Now, what if I change the question? Now, this is a question for everybody. I want everyone to try this. What if I was picking an animal? What's the chance that it's either a hippo or a black animal? Alright, who wants to take this one?
I'll take it.
Is this Abhinav? Alright. Yes, go
Oh.
ahead.
It was lucky, but all right.
What? Oh, it was you?
Yeah.
Actually, you just went. So let's give Abhinav a chance, but everyone else try it
Alright.
and then send me the answers
Alright.
through private chat.
Yes, sir.
Wait, can you tell me all the colors again? Elephant, hippos, rhinos, foxes.
Yeah.
You
So
still give
there
us a chance to pick the ball, bro.
two
You never
gray
gave it to me.
2 gray foxes and 2 white foxes. Alright? 10 gray elephants, 6 black elephants. And then 9 gray hippos and 1 black hippo, and 5 gray rhinos, 4 black rhinos, and 1 brown rhino.
Hello.
Yes, Sabino?
I'll answer.
Alright.
So what I did was, since you said it was hippos and black animals, there's 10 hippos.
Yeah,
There's 4 black rhinos, which is 14,
yeah,
and then you add 6 black elephants from elephants.
yeah. So what's
Just
the
20 over 40, but you can simplify to 1/2.
Oh, very good, Abhinav. Very good. Beautiful. Does everybody see how Abhinav got 20 over 40?
Yeah.
Yeah.
Pradyum, do you see how he got 20 over 40?
Yeah.
Are you sure?
Yeah. I just complicated it for myself. I understand though.
Okay. Okay. So what happens here is that I can do it another way too, right? If I get all the hippos, that's 10. And now I get the black rhinos, that's 4. Now I get the black hippos, that's 1. Because I have 1 black hippo. And then I get the elephants. But guess what? This black hippo is already counted in these hippos because I counted them all. I'm counting them twice, so I gotta subtract 1. So what happens? That's 21 minus 1, that's 20. So 20 over 40 is what it is. Alright? Does that make sense?
Yes, sir, that makes sense.
Are we clean?
Yes, sir. I'm clean.
Is everyone else clean?
I'm clean.
Okay. I guess Kaisha is not clean, but... Kaisha, are you clean? Kaisha? I cannot hear her if she's saying something. Or if she's gone. Whoop. Alright. Now that we did this, I'm gonna teach you something a little special today. Alright? So, you guys ever heard of, like, passwords? Let's say you've like a basic iPhone 6 or something where you got 4-digit passwords, right? And then they can be numbers from 0 to 9, right? If you were trying to hack somebody's phone and you didn't have all these technologies, right? How would you do it? Anybody? Okay, who left? Who left the call? How dare you? Okay, Kaisha left the call, I guess. Lucky, what did you say? Okay. Alright, yeah.
That was for that problem, Pritamana.
Okay, yeah, no worries. I thought... Alright, is Kaisha back? Alright, I'm trying to switch into this, but I'm not able to for some reason. But...
I'll have answer.
Okay, Pradyum, what is your answer?
Fraction form, right?
No, I'm not even asking you about any fraction format answers. Saying that, alright, you want to crack somebody's phone password. And it's an iPhone 6. Where
Yeah, there's only 10 digits.
What?
Yeah, there are 4 like possible like spots, and then there are like 10 digits that you can
My question is, how are you gonna do it?
Oh, how am I gonna do it? Like there are 10 digits in each thing, so
Stop
the probability of getting the first one.
Stop talking about numbers and digits. The question is, if I give you a phone to your hand, what are you gonna do?
Try to open it.
Okay, I guess Kaisha was having network issues. But yeah, how would you open it? You gotta, type in the password, right? Type in the password. That's what I was looking for.
I'm gonna type in the password.
Yeah. So, now, that we know that you're going to type in the password, right? So,
Yeah.
like if you type in, right, let's say the password is some complicated thing, right?
Yeah.
You're probably going to have to keep trying a bunch of times, right?
Yeah.
You probably won't get it on the first try, right?
Yeah.
So, you know how many times you'll have to try if, like, you were wrong every single time? Like Pradyum was saying
Yeah.
earlier, we have 10
1 out of-
Pradyum, do not talk when I'm talking. There are 10 possible digits in here, right? Lucky, Abhinav?
Right here.
Yes, sir.
Are you with me?
Yes, sir. I heard you.
Alright, there are 10 possible digits you could pick from. And the 10 can go here. There are 10 choices you gotta try here, 10 choices you gotta try here, and 10 choices you gotta try here. So if you write them all out, you know, you got like 10,000 possible passwords you gotta try. And by the time you type all
Yeah.
them in, you know, the guy's probably gonna come back and take his phone from you. So you lose.
There's like 1 chance that you get it right because the password's unique.
Yes, Pradyum, but we're not there yet. I do not appreciate you talking when I'm talking. Let me make that clear. Very clear. Okay?
Okay.
This is your last warning.
Okay.
Okay. So these are the possible passwords you gotta try. Possible passwords. The number of ways that something works, right? You know what all these possible ways are called? They're called permutations. Permutations are the number of possible ways certain things can be done. Right? Let's say I go to the store, right? I want to buy, you know, Kinder Buenos, fried chicken, and ice cream, right? I can first go buy ice cream, or I can first go buy either one of these. I can buy second, either one of these, or third, right? No matter which way I buy them, right? I'm still getting the same things in my hand at the end of the day, right? That order does not matter. Where the order does not matter, it's called combinations. Order does not matter. Okay, is that something in the chat?
Abhinav said he's going to the restroom. He's gonna come back.
Okay. So, do you guys follow this so far? There's combinations and there's permutations. There are ways to count how you do certain things. Right. Did Kaisha just join back? Okay. So looks like not. But yeah, anyway. Okay, I
We'll
guess
be back.
Kaisha is back.
I'm gonna be back. I have to go to the restroom.
Alright, while you guys are gone, I'll just brief Kaisha on what happened real quick. So, Kaisha, when you were gone, we were talking about certain things called permutations and combinations. Oh, Kaisha cannot hear anyone. Lucky?
Yes, sir.
Kaisha, can you hear Lucky?
Yeah, now I can.
Oh, me
Hello?
or Lucky?
I can hear all of you.
Oh, you hear everybody? Alright, yeah, no worries. No worries.
Yeah.
Alright. That's good. Wait, where's Rabina?
No, Binav's at the bathroom.
Can you-
Pradyum's at the
can-
bathroom too.
Oh, okay.
Yeah.
Alright.
Okay, anyway, Kaisha, while you were gone, we were talking about things called permutations and combinations. So they are the number of ways you can count the ways you do something, right? So like let's say I give you a phone. I give you a phone and that's got like, 4 digits. It's a basic iPhone 6 that you got, right? And then you want to guess somebody's password, right? So if you want to guess somebody's password, you try for a bunch of times. You keep typing random numbers in. So those random numbers are called permutations. They are the number of ways you arrange the numbers to get something else. It doesn't just have to be numbers, it can be anything. Right? And now if I go to a store, I want to buy fried chicken, ice cream, and Kinder Buenos, right? I can buy them in any order and I'll still have the same thing, right? Where the order matters, it's called permutations, but the order does not matter, it's called combinations. Like the store, that's a combination. Password is a permutation, because if you type it in the wrong order, it's wrong, right?
Yeah.
Does that make sense?
Yeah.
Alright. Now we are going to do something called factorials. Have you guys heard of these factorials? Kaisha, Lucky, Pradyum, Abhinav?
I've never heard of factorials.
Okay, so I'll tell you what a
But-
factorial is. Sorry?
Can you scroll up?
Yes. Do you have a question on something or something?
What?
No, like, I asked if you have any questions on this, or is there a reason you asked me to scroll up or something?
No, I just want to see a word. So
Okay, what's the word?
permutations.
Okay, permutations is where the order matters, right? It's like your password. Combinations is where the order does not matter. It's like you go into the store. You get them in any order. You're still having the same stuff in your hand at the end, right? I mean, yeah, you could go to Publix right now and maybe get some ice cream, some fried chicken, and some frozen stuff. In any order, you're still gonna walk home with the same things, right? The same thing's gonna go into your fridge. Okay, yeah, Lucky, what were you saying?
I was asking if you could just explain the factorials thing, because that's what you said you were about to explain.
Yeah, I will. Let's wait for the
Alright.
other two, because I
Yeah.
will-
Pritamana,
Yes.
I'm back. What did I miss?
Nothing really. I was just like saying everything like Kaisha missed. So you were there for all of that. But yeah. Permutations is like you typing in a password. Every possible password you type in is a permutation. And that's where the order matters. Combination is when
Yeah.
you go to the store and you're trying to buy fried chicken and all their good stuff. In any order, you buy it in any order, you're walking home with the same things. And the same things go into your fridge. Right? So that's where the order does not matter. Does not matter how you buy them. Alright?
Mhm.
Okay, is Pradyum back? Okay, anyway, I'll just get started with factorials. He'll catch up later. Okay, so a factorial is one of the most beautiful things that you'll ever see, because I'll tell you what it does. Right? It is the product of all integers from 1 to a given number n. And by the way, 0 factorial is considered 1. If you have an exclamation mark after the 0 or anything, that exclamation denotes a factorial. Alright? Alright, does that make sense? Everybody. So you see, 1
Sir.
factorial
Got it.
equals 1, right? 2 factorial equals 1 times 2.
Uh-huh.
Yeah. 3 factorial equals 1 times 2 times 3. Alright? So now we're gonna do some drills. I'm gonna make you guys memorize factorials from 1 to 8. Alright? 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. Lucky, what is 5 factorial? No calculator. Go.
Wait, 5 factorial is 1 times 2 times 3 times 4 times 5.
Yeah.
Yeah, alright, hold up. So 1 times 2 is 2 times 3 is 6. 24 times 5. 120.
Very good, Lucky. Abina, what is 6 factorial?
Alright, 1 times 2 is 2. 2 times 3 is, what's it called? My cuckoo brain, 6. 6 times 4 equals 24. 24 times 5, I believe it's like 120. Alright, this is a hard part. 120 times 6. Give me a second.
Yeah. I faced 120 balls in a game and hit all of them for 6s. Calculate my score.
720.
Very good. Very good. Yeah. Your dad hit 6s too. But yeah. Anyway.
Do you know if they won?
I mean, they're in the playoffs, man. My team didn't go through. Yeah, I guess they missed me, but not really, because they won the last game when I was not there. Alright, anyway. Yeah, now that we know this, Abhinav, did you notice something? 6
What?
factorial equals 5 factorial times 6.
I'm back.
Yeah. Like, if you notice something, you would see that 6 factorial, right, has 5 factorial in it.
Mm-hmm.
Alright,
Oh,
Kaisha, I
I
want you to
see.
find 7 factorial, and Pradyum, I want you to find 8 factorial. No calculator. Go.
For 7 factorial, it will be 5040.
Wow, that was quick. That was quick. Okay, very good. Pradyum, I'm waiting for you. Good job, Kaisha. Very good job.
4320
For what?
0
Yeah?
3
Yeah?
2 0.
You know, this thing is called 40,320. You could have said that and made it a lot easier for everybody.
4320.
Yeah, I thought he was saying this, man. I thought he was saying this. I thought, wait, how can 8 factorial be smaller than 7 factorial? Come on, man. You guys wilding, honestly. You guys wilding. But yeah, anyways, now that we got to factorials, I'll tell you how to count. Right? Alright, let's say I have like a 4-digit password, right? And I cannot repeat the letters. Not letters, but numbers. Right? No repeating numbers. Right? I have 0 to 9 that I can use for each. How many passwords can I make? Alright, how many passwords do you guys think I can make with this?
I know.
Let's talk through it in English first. Anybody using numbers is getting a strike. Do not use numbers. Talk about it in English. And tomorrow we're gonna solve Python problems with the same kind of things. I'll show you how to do this and show you the beauty of Python. But anyway, so anybody has any ideas first? Do not use a single math word. You use a math word, you get a strike. Do not use math words.
I'm not volunteer. I bet. I can't volunteer.
Oh, you don't know English? Okay.
You know hablo English.
Okay, well, I guess I gotta put you in an English class now. But yeah. Okay.
Yes, I'm in.
Lucky, Abhinav, Kaisha, Pradyum. Any ideas?
Okay, so don't repeat them. Is that a 9 or a 4?
I don't know how to explain it in
Dude,
English.
he said not to talk in numbers.
No, he uses
No,
numbers like that, but
Well, if that was 9 or a 4, you do a dash through the thing. I got confused.
alright. So yeah, Kaisha, you said you can't explain it in English. Alright, let's just try whatever you know, and then we'll clean it up from there.
I think we are multiplying.
Okay, do not use that word.
Um,
Okay, so let's talk about it. If I use a number here, let's say I use an X here, can I use the X here?
no,
Yeah, so we can't use the X there. So if I use a Y here, can I use a Y here? Y or an X here?
Oh.
No.
So we have a third number, Z. Now if I use X, Y, Z here, can I use any of the numbers here?
No.
No.
So alpha. But guess what? How many choices I got for X here? It's not just one. It's 10 because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. Right? I can use 10 numbers here. Right? And now I can't use only the X here, so I get 9 numbers there. I can't use X or Y, so I have only 8 numbers to pick from. And now I only have 7 numbers to pick from. But guess what?
Wait, so
Wait, I'm not done talking yet. No one is
My
allowed
bad,
to
sir.
talk until I give you the license. But guess what? For every one number I pick here, I have these many choices for the second number, these many for the third, and these many for the fourth. Now I'll tell you. So let's say I pick a 1, right? I can pick anything from 0, 2, and 9 here. Alright, let's say I pick another number, right? That's 9 choices there, right? Let's say I pick a 0 here. I can pick anything from 2 to 9 here. So that's 8 choices. And now let's say I pick like 2. Now I can pick anything from 3 to 9 for the last number. That's 7 choices. And for every one number I pick here, I'll have 9 here, 8 here, and 7 there. So my total number of passwords would be 10 times 9 times 8 times 7. Does that make sense?
yes, sir.
And so,
Isn't it just like the reverse thing you were talking about?
The reverse?
Of how do you say that word?
The factorial?
Yeah, it's like a reverse of that.
Not really. Yeah, it is kind of a reverse, but I'll get to the definition. I'm sorry guys, Abhinav spoiled it. I was gonna say something that blows your mind about this, but hate you, Abhinav. Alright, it's fine. It's fine. So yeah. We
My
have
bad.
10 choices for each one, right? And then we gotta pick 4 digits. So the permutation formula is going to be n factorial divided by n minus r factorial. Where r here is 4 because we want 4 digits. N is the total digits. Now you guys might be thinking, alright, what is this guy saying? Alright, yeah. So now we got 10 factorial here divided by 10 minus 4 factorial, right? Which is 10 factorial divided by 6 factorial. Now, you know what 10 factorial can also be written as? It could be 10 times 9 times 8 times 7 times 6 factorial. Because, like, 6 factorial is basically 1 times 2 times 3 times 4 times 5 times 6. And it's the same thing, right? They cancel out. And now you got 10 times 9 times 8 times 7. Which is... Alright, what do you guys think? Find the number for me. 50, 40. Alright? Can somebody confirm that number?
Yeah, it's
Yeah,
15, 40.
it's 50-40.
Alright, not bad. I still got it. Okay, so the formula for permutations. I did not want to introduce it this way, but I'm sorry, guys. This is how permutations works. You see, if I were to give you like a password of like only alphabets, right? 26 alphabets, and I wanted like a 2-digit password. How many passwords could I make? We're gonna use the same thing. We have 26 choices for the first, 25 choices for the second. If you put it in the formula, that's how it's gonna work too. Does everybody see how this works?
Yes, sir.
Are we all clean?
Sure, I'm clean.
Yes, sir.
Kaisha, Lucky, Pradyum?
I said yes, sir. I'm clean.
It's sir, I'm clean.
Okay, Pradyum, are you clean?
Yes, I'm clean.
Okay, very good. Okay, now fun problem time. Oh, by the way, tomorrow with Python, we're gonna write factorial programs as well. So you're gonna see how funny this is. And this part of math is called combinatorics, which is a big field in math. I used to be very good at this when I was in college, but you know, I lost some of my skills. I'm picking it up because I last did this 4 years ago. But anyway, we used to write these big programs to calculate, you know, who's gonna win the games and all that. We used to fix cricket games like that. Not fix, but then like, you know, predict cricket games with all this. It's a powerful tool. Alright, so let's say I have a 2-digit password. And I have letters from A to Z that I can use. How many passwords do I have?
26 into 24.
Very good, Kaisha. 26 into 25, like I just said that. But I want you to explain this with the formula that I told you about. Alright, Kaisha, I want you to explain it with the formula.
So first n equals 26
Yeah?
over 26 minus 2.
Why is it minus 2? What is R?
The number of digits.
So in this case, that's 2, right? So our
Yeah.
formula is n factorial over n minus r factorial, right?
Yeah.
So this is 26 factorial divided by
Over.
24 factorial, right?
Oh, okay.
Yeah, I mean you got it right. So which essentially is the same thing as 26 factorial over 26 minus 2, right? Isn't that what you were saying?
Yeah.
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 So that's 26 factorial divided by 24 factorial, which again, we know that 26 factorial is 26 times 25 times 24 factorial. Yes? If we expand it that way.
Yes, sir.
So they get canceled out, and you got 26 times 25.
Yeah.
All right. Does everybody see how we got this?
Yes,
Sir.
sir.
Are we clean, all of us?
Yes, sir.
Are you sure?
Mm-hmm.
Listen,
I don't see very strong answers.
I'm sure.
All right.
oh, very
So
sure.
I got 650 passwords. Did you guys get the same?
Yeah.
Yeah.
Yes.
Yeah.
Yes.
Sir.
Ah,
Okay. All right. This is your ticket out the door. Let's go back to our hippos and rhinos. All right. So I have a boss hippo, boss elephant, and now boss rhino and a baby fox. If I were to make them stand in a straight line, how many ways can they stand? One behind the other. First, let's think about the problem in English, and then try to use math.
So
to
so
solve.
they are four animals?
Yeah. Baby fox, boss hippo, boss elephant, boss rhino.
Is it 16?
How did you get 16, Kaisha?
4 into 4?
Why is it 4 into 4? Does anybody have any other ideas?
how many ways can
They
they
stay.
stand? Basketball.
I mean, I got one.
Are we using the formula?
Maybe, maybe not. That's why I'm saying. Alright, think about the problem in English first.
Mm, so there's 4 digits, I guess, where you can put it.
Alright,
And there's
how
4
many choices do
animals.
I have for the first place?
4.
4.
Yeah, so a guy standing first, can he stand again?
No.
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 Alright, so I have 4 choices for this guy. Right? Let's say I put
And then
my...
3, 2, 1.
Yes. Right? Let's say I put the boss hippo here. He cannot stand anywhere else. If I put the boss elephant here, he cannot stand anywhere else. I put the boss rhino here, can't stand anywhere else. Baby fox, he's got to stand last. But no matter who I pick here, I'm only going to have 3 more choices here. Right?
Mm-hmm.
So the answer is 4 factorial. Or 4 times 3 times 2 times 1, which is 24. 24
4.
ways.
Yeah. 2 ways.
Wait, can you tell again?
Yes. You see, Kaisha, I have 1 boss hippo, 1 boss elephant, 1 boss rhino, and baby fox. Right? So if I were
Yeah.
to pick one of them first, right? If he's standing in one place, he can't stand at the other place, right?
Yeah.
Okay. If that guy's gone, I have 3 more people I can pick from. If another guy's standing at another place, he can't stand anywhere else, right?
Yeah.
Then I have 2 more. Then I pick 1 more, then I have 2 choices from there to pick. And then if he's standing there, the other one's gonna stand at the back, right?
Yeah.
It's just like our passwords, right? If you pick a character here. Wait, I'll tell you. Yeah. Wait, where did the passwords go? Oh yeah, the 650. Oh yeah, right here. So yeah, you see in here we have like 26 digits, and then we got picked from 2 places where you cannot repeat them. right? It's the same. We have 4 animals. And I cannot repeat one after the other, right? Because they're all different animals. Right? So it's the
Okay.
same thing.
Yeah.
Alright. So, feedback time. The recording